Welcome to Brain Vision.
If we want to turn the graph into a straight line, we need to get it into slope, or we need to get t as a function of x, or the y variable as a function of x, and y equals mx plus b, or slope-intercept form. So we can do this by realizing that for no initial velocity and no initial position, x is simply just equal to 1/2 times the acceleration times t squared. So for a, all we need to do is just turn the y-axis t into t squared. So after squaring all the t values and then replotting this in so, we get a best linear fit equation of t squared is equal to 0.2657 x minus 0.0057. Rearranging this in a more familiar form, we get x is equal to 0.021 plus 3.8 times t squared. Okay. So then part C now asks for the acceleration of the glider. Well, since we know that x is equal to 1/2 times a times t squared, then we know that 1/2 a t squared must correspond to the 3.8 times t squared in the above equation, which, solving for a, gives a is equal to 7.5 meters per second squared. Now we want to find the final velocity of the glider, knowing this acceleration, and knowing that its initial velocity is again 0. So we want to use the velocity as a function of time equation, which is the final velocity is equal to the initial velocity plus acceleration times time. Initial velocity is 0, so this is just simply 7.5 times, oh, you know what, actually we don't know time, so we want to use velocity as a function of distance, which is v of squared is equal to the initial squared plus 2 times a times yf minus y initial. V of squared to 0 plus 2 times 7.5 times the change in distance, which we're told is 1.35 meters. So multiplying these all together and taking the square root, final velocity at the bottom of the ramp is 4.5 meters per second. Finally, we want to calculate, actually that was it, that was part D. So we're done there. Final velocity when it gets to the bottom of the track is 4.5 meters per second.